head of the Department of Physics of Stellar Systems of the Institute of Astronomy of the Russian Academy of Science. Please, you're welcome.
Thank you. Yes, I am Oleg Malkov. I work in the Institute of Astronomy of the Russian Academy of Sciences, and also I give lectures in Lomonosov Moscow State University. About 15 years ago, UN decided that 2009 would be International Year of Astronomy. And it was a worldwide event, and in different countries, different bodies, authorized bodies, organized a very large number of various events. And one of them was organized in our country. We have compiled a list of 35 questions concerning astronomy. They begins with when. For example, when a man will land on the Mars, or okay, human, yes, Homo sapiens will land on the Mars, man or woman. When white holes will be discovered, and etc. This list was compiled by my colleagues, professional astronomers, popularizers, and some scientific journalists. Russian astronomers were asked to answer the questions. The questionnaire was also available to amateurs of astronomy, and we processed the answers separately. And it will be the topic of the first part of my lecture, the results. As to the second part of my lecture, 15 years have passed since that time, and some of the predicted events have already taken place. So we have an exceptional opportunity to compare our predictions and the real life. Our list of professional astronomers contained a little bit more than 100 astronomers. The majority of them were PhD plus, which means candidates, doctors, members of the Russian Academy of Sciences. Is that a lot or a little? We can compare this number with the number of actively working Russian astronomers. There is an International Astronomical Union, which is the most authoritative institution, astronomical organization in the world, and it collects several thousand of members, and some 350 of them are Russian astronomers. And this number approximately corresponds to number of active Russian astronomers. And this means that our respondents were about 1/4 of all reputable Russian researchers. How did we process their answers? We expected to have answers in a form of some particular year, for example, in 2050. These answers were collected and averaged. Here is a short description of procedure, how we averaged the answers. We used quantile method. Sometimes we got answers never or I don't know, and it was allowed. For each event, we calculated not only mean and dispersion value, but also the probability that this of that event would happen. And this probability was calculated, and it depended on number of never answers. So it was just a ratio of never answers and 119. Also, we sometimes obtained forbidden answers. Sometimes respondent answered that this particular event will happen in some interval, like 2015, 2020, or 40th, and we have replaced this interval by some mean, rough mean values. Sometimes we got upper limits, like by 2100, and it was replaced by pessimistic 2100, and contrary, when we had after some date, then it was replaced by optimistic date. In some cases, we got answers like soon, today, tomorrow, and it happened in 2009, so it was replaced by 2009. Other forbidden answers. In some cases, our experts decide that it's not necessary to achieve this goal, to study this problem, and consequently we had an answer like needless, no need to study this, and it was replaced by never. Or at any moment was substituted by I don't know. And in some other cases, we had answers like it is already done. And it meant that our question is probably not quite correct. And such answers were not averaged, but were processed separately. And now we come to the results of this survey. Some events were decided to be very unlikely. What does it mean? It means that less than half of our professional astronomers decided that it will happen sooner or later. The majority of them decided that it will never going to happen. And among them are discovery of a new solar system body larger than Mars, displaying of convincing proof of an extraterrestrial civilization's visit to the Earth in the past, discovery of white holes, and discovery of Dyson spheres. I would just briefly remind you what is white hole. In the analogy of black hole, white hole is a hypothetical region of space, time, and singularities that cannot be entered from the outside. And another interesting thing is Dyson sphere. Again, I will remind you that what is Dyson sphere? Imagine that when we live on the Earth and we would like to collect as much solar energy as possible, and we have possibility to construct a sphere around the Earth orbit or even larger to collect solar light, solar energy. Of course, it's just a hypothetical construction, and there is a lot of even theoretical problems in constructing such a sphere. One of them, and probably the most important, is inevitable rotation of the sphere, and it should be deformed and so on with some consequent problems. Nevertheless, we put this question. Within the next few years, here I give the answer, the averaged answer, some kind of the error, and probability of this event. So, in 2018, astronomy again becomes an obligatory subject in Russian schools, as it was in the Soviet time. In 2024, plus 11 minus 7, a sample of Martian soil is transported to the Earth. Remarkably, all our experts decide that it is an inevitable event. Approximately at the same time, water on the moon will be discovered. In the late 20s, with 90% confidence level, a permanent astronomical observatory in the South Pole will be established. Nature of gamma bursts will be unraveled, and it is, in fact, it's confident, and moreover, significant number of our experts answer that it is already unraveled. And approximately at the same time, active study of Venus will be recommenced. As to the observatory in the South Pole, actually some pilot projects exist, and as far as I remember, some spectroscopic observation in particular were done in the Antarctic region. However, an analysis showed that there is some systematic errors in the spectroscopic results, errors connected with problems arised from the low temperature. So our modern equipment, our modern telescopes still cannot work in such conditions, so it is probably a task for some future. The 30s, 2030, plus 42 minus 15, intermediate mass black holes will be discovered. 2032 plus 28 minus 17, gravitational waves are registered. I remind you, it is in 2009. But if you calculate 2032 minus 17, then you will get 2015. And we will talk about it later today. Next, extremely massive, more than 200 solar mass stars are discovered. But the probability of this event is not very high. And 100-meter optical telescope is constructed, also somewhere in the 30s. This is a picture of probable potential 100-meter optical telescope. The 30s. We continue. 2034. Regular flights of private spacecraft begin, and it is almost confident. Approximately at the same time, satellites of planets are discovered, and I draw your attention to very low, relatively low dispersion of this event. Also, in the first third of the 30s, an exoplanet with all 4 biomarkers, water, carbonic acid, methane and oxygen will be discovered. And again, the level of confidence of this event is surprisingly high. Nature of dark matter is unraveled. A human lands on the Mars, also very high level of confidence. Solar sail is used for space flight, and in 2040, existence of black holes is unambiguously proved. Actually, here we speak about black holes of stellar mass. As to the black holes, supermassive black holes, their existence is, of course, already proved. And as to the stellar mass black holes, about 1/3 of our experts answered that is already proved. However, I think that it's not the case. I discussed this with experts in black holes in closed binaries, and they prefer to say candidate to black hole rather than black hole itself. Hmm? Mm-hmm. A few words about dark matter. Actually, you know about this problem. What is dark matter? It is something that we cannot see, but we can guess the existence of this matter due to its gravitational interaction with some other bodies. And as far as I understand, this problem began with the comparison of rotational curve of galaxy, our galaxy, and neighbor galaxies, and the behavior of bodies of stars on the periphery of galaxies do not reflect the Keplerian motion, and it means that there is something else in the galaxy which we cannot see, and it's not stars, it's not gas or dust. It is something dark. Either it is something very massive, like black holes, or contrary, it is something very numerous, like brown dwarfs, or probably even elementary particles. There is a list of candidates to dark matter. It is both baryonic and non-baryonic matters, but in any case, this question is still open. However, recently, if I'm not mistaken, about a month ago, I have seen an interesting data from James Webb Telescope, and according to this data, we probably make a mistake constructing a rotational curve of galaxies. So it should be double-checked. Probably this problem will be solved in near future, and probably the amount of dark matter should be significantly reduced. The amount of the expected dark matter should be significantly reduced. In the late 40s, permanent astronomical observatory on the moon is established, almost for sure. Nature of dark energy is unraveled, almost for sure. Nature of the red spot on the Jupiter is unraveled, sure. And again, a significant number of professional astronomers decide that it's already unraveled. Observatory on the moon. Please laugh and applaud, but it's unfortunately just a picture. As to the dark energy, you probably remember that we were forced to involve this term, which is, by the way, about 70% of all the universe. We have to involve this to explain somehow the acceleration of the galaxy expansion. We have no idea about what is this. We have no assumptions what it can be this dark energy. So probably it is you who provided us, who will provide us with answer of this question. The 60s. 2057, tourist space flights are widely available. Approximately the same time, a manned or womaned flight beyond the Martian orbit takes place, and a sample of Saturn atmosphere is obtained. Also, the 60s. Wormholes are discovered in 2065. Approximately at the same time, mankind begins to use extraterrestrial sources of raw materials. And 2068, it's written here, mankind finds assured protection of the Earth from asteroid and comet impact hazard. It is just a picture of wormholes. You remember one of my previous pictures with black hole and white hole, and if we assume that these two regions of the space are connected somehow, that this connection, this tube, we call wormholes, and it is a rather convenient way to transport something from black hole to white hole. Of course, it's just a hypothetical construction, and we are not sure that it will be discovered. At the end of our century, 2082, a fraction of solar energy in the mankind's industry exceeds 50%. Public transportation circulate on the Earth-Moon road, and at the end of the century, the Earth is expected to finally encounter with an asteroid larger than the Tunguska body. I would remind you that 30 years ago, we already constructed something which can protect the Earth from asteroids. So for us, for the civilization, it will not be really dangerous, this asteroid impact. And the last portion of questions, not very soon, not very accurate, not very likely. It will be in the next century, plus minus 1, 2, or 3 centuries. A radio signal of extraterrestrial intelligence will be detected with rather low level of confidence, and a contact with extraterrestrials will be established. Another interesting statistics is it is connected with the number of answers like I don't know. When a large number of experts answered I don't know, we consider this question as rather difficult. And among the most difficult questions are: when white holes will be discovered, Dyson sphere, and intermediate mass black holes. Only slightly more than half of professionals could answer these questions. And as to the most simple questions, where almost 100 respondents answered, were a question about 100-meter optical telescope, permanent astronomical observatory in the South Pole, and a question about the protection of the Earth from asteroids and comets. Then, as I told you above, we also asked amateurs. And on this view graph, I compared answers of amateurs and professionals. and it is probabilities of events. Amateur probability versus professional probability. Altogether, the group of experts, of amateur experts, contained 55 persons, and well, black dots are the least probable events in professional version, and you see that the correlation is rather good, with a couple of exceptions, and the most prominent outliers are proof of an extraterrestrial civilization visit to the Earth in the past, where amateurs consider the probability to be about 0.7 or something like this. And from the point of view of professionals, the probability is rather small. Actually, it's quite understandable, because it is not an astronomical question; it is a more philosophical question. But now you know astronomers' point of view on this matter. And another outlier is water on the moon. Here, professionals were more optimistic, much more than amateurs. And here I compared the answers, the date when such and such events happen. Red line again is bisectors, and you can see that amateurs in general more pessimistic than professionals. Their dates are much larger than dates of professionals. The majority of points reside above the red line. What are the events? Contact with extraterrestrials. We professionals think that it will be in 22nd century. Amateurs suggest the middle of 23rd century. Satellites of planets. Again, amateurs are much more pessimistic. Water on the moon. Asteroid impact protection. Tunguska encounter. And I would like to draw your attention that according to a professional point of view, we first construct some protection of the Earth, and then after some 30 years, we will meet new Tunguska. Amateurs are more pessimistic. First, we will meet Tunguska, and after that, after this meeting, the governments of your countries decided that, yes, we finally have to support this work on the construction of study of the vicinity of the Earth in the solar system, and construction of some protection for the Earth. I think that this point of view is more realistic. I mean, the amateur's point of view. What else? Wormholes and Earth-Moon public conveyances. When we collected the answers, we also allowed our respondents to give some comments. And we indeed received some comments. The majority of comments were skeptical. We received some phrases like solar activity problems are not touched at all, incorrect question, what other proof you mean, and so on. So this is examples of what we had from our respondents. And the number of such skeptic comments was about 10. As to the approval comments with approval, we receive thank you, it is an interesting idea. And the number of such comments was 1. Here is the conclusions for the first part of my lecture. Such forecasts are always subjective. They rather indicate most interesting and strongly studied areas of knowledge. So it can be considered as a fun. However, our experts are not any passers-by, but about 100 of venerable professionals who know problems and perspectives of present-day astronomy better than anybody else. So this forecast, this prognosis, is the best that we can propose today to you. The second part, definitely this part will be shorter than the previous one, are confirmations. So again, 15 years have passed, and now we know that some of the predicted events have taken place. Intermediate mass black hole is discovered. Here I give reference, and I give date when it will be announced. So we can compare, and we will compare this date with our 15 years old predictions. Solar sail is used for space flight. Icarus, spacecraft with a solar sail prepared by Japan Space Agency, and it was launched in 2010. The most massive star was discovered also in 2010. Strictly speaking, it is not calculated mass. It is estimated mass. You know that we can calculate stellar masses only if our star is a member of a binary system of specific observational type. In all other cases, all we can do is to estimate stellar mass from another parameter. As a rule, it is luminosity, sometimes it's spectrum. For this particular case, the mass was estimated from the mass-luminosity relation, and using the luminosity of the star, it was again estimated that the mass of the star is 2,500 solar mass. Anyway, it's more than 200 mass, and strictly speaking, we have to consider this event as a confirmation of our prediction. And water in the form of the ice on the moon was found by a lunar reconnaissance orbiter in 2012. Water ice was discovered at a mass fraction of 5 to 10% of the material making up the walls of the Shackleton crater on the south pole. Gravitational waves. Gravitational waves were discovered in 2015. You remember that it is on the edge of the predicted interval, which was predicted by our experts. Gravitational waves is the product of, strictly speaking, gravitational waves detected by our instruments is the product of the merging of two black holes when they form one more massive black hole, and Nobel Prize in Physics was awarded to this discovery in 2017. Astronomy was returned in Russian school, and beginning from 2017, our former Minister of Education returned astronomy to school. However, from this year, astronomy is excluded from the list of compulsory school subjects, unfortunately. Samples of Saturn's atmosphere was obtained by Cassini when it completed its 20-year mission to the system of this planet and burns up in the atmosphere. And finally, recently we observed the end of the stage of the OSIRIS-REx mission. It's not the end of the mission, it's the end of this particular stage when the probe of the OSIRIS-REx launched 7 years ago, flew past the Earth and dropped a capsule with soil samples from the asteroid Bennu. So now we can compare these dates of these events with predictions, and we can see that we underestimate our own capabilities. Here's our predictions. It is a plan, and this is a fact. And we expected to meet these events in 30s, 40s, but it has already happened before 2020. Not yet confirmed, but under study. It is probably the candidates in the next version of my presentation, which I will produce in several years. Satellites of the planets. It is assumed that one of the satellites of Saturn have rings, but it should be confirmed by further study. Exoplanet with biomarkers. Hot Jupiters are very numerous now, and warm Neptunes as well are considered to be good candidates to comfortable, from our point of view, comfortable planets. And we hope that Spitzer and James Webb and other future missions will help us to answer this question. Great red spot being studied by Dewey and energy source not yet clear, but I also think that this question will be solved in near future. A new big body in the solar system. You all remember a discussion about potential 9th planet in our solar system. Unfortunately, we have no idea about where we can find this planet, but the search is ongoing, and probably a body larger than Mars will be discovered as a new planet of our solar system. The nature of gamma ray burst. Actually, I think I'm almost sure that the majority of you think that this problem is not a problem. It is already solved, but actually there is several mechanisms which are considered, and we consider them as strong suggestions for the nature of gamma ray bursts, but it also should be confirmed. Dyson sphere. I consider that this problem is already closed with negative answer. However, a recent discovery of so-called Tabis star, I remind you that it is a variable star with unusual light curve, and some. I will just say what I know about this, and I know not a lot, and I believe that there is a natural explanation for the behavior of a Tabis star, but first interpretation of this behavior were connected with Dyson sphere. A few words about plans. Exploring of Venus is scheduled for tomorrow, actually, and delivering the first person, the first mankind to Mars, is scheduled for the end of 20th. At the end of my lecture, I would like to acknowledge my colleagues who helped us to collect, to distribute these questions, to compile the list of questions, to distribute this list, to collect the answers, to analyze the answers, to make mathematical analysis. I also would like to thank the organizers for inviting me to give this talk here, and I ask audience for your attention. That's my talk. Questions, please.
Mr. Oleg, nice to meet you. I'm Jose Angel from Venezuela.
Glad to meet you.
Have you ever wondered different chemistry to sustain life different from water?
It is it is a very interesting, very big, and very dangerous question. When we look for extraterrestrial life, when we look for planets comfortable for us, we use this non-correct approach that all civilizations should be like us. We call it carbon chauvinism. Theoretically, we can at least we can make a model of other civilizations based on sulfur, on some other base, and for them, definitely, the conditions, the comfortable conditions should be quite different from ours. So what I told you today, it concerns, unfortunately, only the planets, the other conditions from our human point of view. So, when we look for planets with biomarkers, it is comfortable for us, but probably it's not comfortable for somebody else. But unfortunately, the only civilization what we have under study is our own, nothing else.
Does anybody have questions?
Thank you. Hello. First of all, good afternoon. And second, what do you think will be the course that humanity should take to achieve objectives set in a shorter time than the estimated?
Say again.
What do you think will be the course that humanity should take in order to achieve the objectives set in a shorter time than estimated?
I think, thank you for the question. I still have to follow the predictions. Some of the tasks are already solved, but some others are not. So if we come back to the beginning of my talk, to the beginning of my lecture, then you will find a list of tasks that should be solved immediately or in near future, at the end of 20s or in the beginning of 30s. So look at the list and you will find the answer of your question. Thank you for that.
Good afternoon. Actually, I've got a question about the Dyson sphere. The first of all, do you think that it is, I don't know, reasonable to construct it? And if it is so, like from what materials we could do it?
Personally, I don't think that it is reasonable. First, and then I think that it is technically impossible to take. In particular, our rough estimations made at the end of the previous century told us that to construct a very thin Dyson sphere to collect solar light, we need a matter. To construct it, we have to destroy Jupiter. Nothing more and nothing less.
And if we have not to build a sphere, but a swarm of some particular objects around the star?
In any case, I think that it will be destroyed by minor bodies, by inevitable rotation. So I'm not an engineer, but I cannot see the way. Well, to construct it's half a job, but to keep it workable, I don't think that it's possible. Probably there are some new ideas about Dyson sphere, but I don't know about them. And well, we in astronomy we don't like to use term belief, but I don't believe to Dyson sphere. I don't think that it is necessary, it is useful, and it is workable. So it's just a hypothesis. I remember that actually when Dyson invented the sphere, the stellar objects were immediately discovered, which look like Dyson sphere. They were almost invisible in optical light, but they were relatively bright in infrared. But later, we found that they are, or at least the majority of them, are brown dwarfs. Brown dwarfs, you remember, it's the bodies which reside on the scale of mass and evolution between planets and stars. So all such objects were explained by natural reasons rather than Dyson sphere or other constructions.
Good afternoon. I have a question. So, which will you think that will be our future energy source?
Future of what?
Energy source.
Oh, again, we will not speak about my personal view on this because it's not professional. But as to the view of my colleagues, you remember there was some answer concerning the solar energy. Mm-hmm. Just a minute. the first item on this view graph, you can see the answer of my colleagues concerning the solar energy. I believe that solar energy is very promising source of energy, but we don't know how much we need to spend time and money to make it really useful for us and to enlarge the fraction of solar energy in our industry to more than 50%.
Since 1835, photography was discovered, and at the end of the 20th century, photography has replaced the human eye at the end of telescope. So all the 20th century, the main discoveries in astronomy were did by means of photography. Photography has the ability to detect, to register, and to show where the electromagnetic energy is. So just wondering, what kind of means to sense the universe will you think will we have to perceive the universe in the 21st century?
Thank you for your question. First of all, I agree with you. As one of my teachers, Professor Samos, says, the era of photographical astronomy is almost exactly coincide with the 20th century. Yes, we use it, photographic means for study of the universe. Now we use CCD and other as instruments. I don't know exactly what we will use even in the near future, because we are speaking now only about electromagnetic spectrum, but we also have gravitational waves, we have neutrino, we have cosmic rays. Sooner or later, we will be able to register them with high enough positional accuracy, and it will be compared with the accuracy of photographical or modern astronomy registering electromagnetic spectrum. So I think that now we are in the era of, as we call it, multi-channel astronomy. And our goal here is to improve our methods of detection and analysis of the signals, and
To give it a meaning.
Yes, to combine the result with the elder results obtained, in particular, obtained with photographic astronomy, because it's very interesting to see how it looks and looked like in, say, B and V Johnson photometry in comparison with, say, neutrino observations.
Thanks. Thanks a lot. May you share your presentation with us?
Anyone else?
Good afternoon. What do we need for the implement and dissemination of the astronomy, like obligatory subject in other countries following the model of Russia?
We recently had a discussion with Professor Samos about that, and we always discuss it with us, with professional astronomers, with teachers of astronomy. In when I was a schoolboy, we have an astronomical course in the last grade, and we don't think that it was very effective, because as to me, I decided to be in astronomy when I was in the first or second or third class. So about 5 years before I meet first astronomical lessons. So probably you are right. It is necessary to implement the astronomy classes in the school. But we think that it is better to make earlier, when a child is 8 or 9 years old, rather than he or she is 15 years old, because the decision to be a researcher or not to be, this decision should be considered earlier. So we think that it is necessary to have astronomy in a school, but in second or third class, something like this.
Me, I don't quite agree. My opinion is that, of course, it shouldn't be the last term, but I don't agree it should be a very early term. I think some time in between.
I was interested in astronomy in 3rd or 2nd grade, so I agree with you.
Well, I also, in the first year, I was first year schoolboy when I was a first year schoolboy when I decided that I will become a professional astronomer, and it happened. But it has nothing to do with astronomical education in secondary school.
Thank you. Anyone else? So I think that's all. Thank you very much for your lecture.